All right, it's time to move on. Now we're going to start discussing frames. All right, so here's a frame problem. And you can say that it's a frame because as I look at the individual members, if I look at this A to E, there's a force here at C, so it's not a two-force member. In fact, there's another one up here at this location caused by the F there. So there's actually four forces acting on that, so it's not a two-force member. It's more complicated than that. So this qualifies for as a frame. But it is not moving. It's still in static equilibrium. It doesn't move under normal circumstances. And so it qualifies as a frame and not a machine. We'll do machines in a later video. All right, so step number one in any of these problems is going to be drawing a free body diagram for the entire structure. So I've got a roller over here at B. And so I'm going to put a force B there, and then I've got a pin over here at A. So I'm going to have an A sub X and an A sub Y, and then I've got W. That's external to the system. The weight is the gravitational force due to the Earth is acting on the system, right? So that's external to the system. So I've got a normal force due to the pin acting on the frame, the gravitational force due to the Earth acting on the frame. We're going to assume the rest of the frame is massless, and then a normal force due to the pin at B acting on the frame. So those are my external forces. There's no other forces external to the frame. All right, so that's pretty nice because we end up with no forces in the X except A sub X. So some of the forces in the X, I get A sub X is equal to 0. So that's a done deal. And then some of the forces in the Y, I've got A sub Y minus W, but that's 100 pounds, plus B, and that's also equal to 0. So I have two unknowns there, right? I don't know A sub Y, I don't know B, and so I need to do the sum of the moments, and I'll do them around A. So I'm going to get W, let's see, so W, this point right here as I go down is 1 foot from the origin, or that y-axis, and then the radius of the wheel is a 1/4 foot. So that's going to be 100 pounds times 1.25 feet. And then I'm at 3 feet plus another foot, 4 feet over. That's going to be B times 4 feet. Now B is kind of trying to rotate around A in the counterclockwise, so that's positive. But W is trying to rotate clockwise, so that's going to be negative. And that's equal to 0. All right, so I get A sub Y plus B equals 100 pounds. That's from here. And then I have 125 pound-feet. I'm going to bring this as negative, so I'm going to bring it to the other side of the equal sign. So 125 pound-feet equals B times 4 feet. Okay, so I brought this term over. And so B is equal to 125 pound-feet over 4 feet. So that's going to be 25 and then another 6. So 31.25 pounds. Okay, so 4 goes into, that's 3 times, goes into 5 once with a remainder of 1, so 31.25 pounds. And so that's B, and so A sub Y is going to equal 68.75 pounds. All right, so I have found the forces on the external forces acting on the frame. That's the first step of the process. The next step then is to break the frame into pieces and then draw free body diagrams for each piece. And then from there, once I've drawn the free body diagrams for each piece, I can solve for all of the unknowns. The first piece I want to do is this wheel here at F, just because it's kind of the odd one here. So here it is, I'm on this center section. This is the point F right there. The radius of the wheel is 1/4 of a foot. There's a tension acting down here. Now, if I do a free body diagram just on W, on the weight, I have 100 pounds down and the tension up, so the tension must be 100 pounds. And so I'm going to draw this out. This is 100 pounds. This is some tension that I don't know. This is F sub x, and this is F sub y. And if I look at the force diagram here, do the sum of the forces in the x, sum of the forces in the y, I'm going to get a system of equations. But then when I do the sum of the moments, and I'm going to choose F, when I do the sum of the moments about F, I get 100 pounds times a quarter foot. That's negative. I get T times a quarter foot, same distance from F. That's positive, so T must be 100 pounds. So when I solve that system, the sum of the moments acting around F, I'm going to get T is equal to 100 pounds. Right, so I've maybe kind of done that fast mathematically, but hopefully you can do that. And then Fx, this is in the x direction, so Fx is 100 pounds in the x, Fy is 100 pounds in the y. All right, so Fx equals 100 pounds, Fy equals 100 pounds. All right, and I'm going to need those here in a little bit as I look at the various members. So I'm going to break it down then. I've done the pulley. Okay, I've done the wheel or the pulley. I'm going to break it down into AE. I'm going to break it down into EB or BD, however you want to do that. And I'm going to break it down into CD. Right, so I'm going to break into those three different systems. Right, those three different members. And I'm going to look at the sum of the forces and the sum of the moments on each of those. So now I take it apart. I do a free body diagram for each individual piece of this frame. All right, so I've done the pulley. Let's do AE. All right, I'm going to do AE. And so AE is looking like this. All right, here's point A, here's point E. And let's see, I've got a force here at C, don't know what that is, and then I've got this tension over here as well. So C is a pin. All right, so here's C, here's A, I think this was E. All right, so free body diagram. We've already done A. So that's A sub Y, and that's a known. And then I have a CX and a CY. And I've also got a tension here, T, which I know the tension is 100 pounds. And then I have an EX and an EY. All right, so this is not a 2-force member or a 3-force member. Okay, so I'm going to have to do the sum of the forces in the X, sum of the forces in the Y. All right, sum of the forces in the X. I've got EX and CX. So CX plus EX equals 0. Clearly one of those is negative, but I don't know which one at this point in time. So I just leave them both positive. The math will tell me. Once I've worked through all the mathematics, I'll get the correct sign. All right, sum of the forces in the Y. Oh, I forgot one. Plus T equals 0, right? Because that's also in the X direction. And then sum of the forces in the Y, I have AY, but I know what that is, plus CY plus EY. Okay? All right, so there's my force equations. Label, I like to list all my unknowns. Okay, the tension I know from the diagram acting on the pulley, and then the outside free body diagram I found AY. So I have CX, CY, EX, EY. So 4 unknowns, but only 2 equations. Well, I can do the sum of the moments. And I'm going to do the sum of the moments about E because I have 2 unknowns up there, and that'll just make life easy. I'm going to eliminate AY and CY because the line of actions of AY and CY pass through E. So they have no moments. So all I really have is CX CX is trying to rotate it in the counterclockwise direction. So that's CX times some distance. And then T is also rotating it in the counterclockwise direction. And that's going to be times some distance. We'll look at those distances here in just a second. And that's going to all equal 0. So I know T is to the right because I know its numeric value. So CX is going to be in the wrong direction. And that's okay. So T, let's take a look at the original diagram. Let's see, C is 2 feet. And then the radius of the pulley is a 1/4 foot. So this is 2 feet, come back a 1/4 foot. So that's 1.75 feet for the tension. And then C is 2 feet. And so I can immediately solve this for CX. I've eliminated one of my unknowns, but I still have 3 unknowns and only 2 equations. That's okay. I don't know what that is yet. I don't know those unknowns yet, but I've only started this problem, right? I've still got 2 more members that I have to look at. All right, so let's take a look at those. I'm going to have, let's do CD because it's kind of nice and easy to draw. All right, so let's look at CD. So here's CD. And there's a force CX and a force CY. And I know CX is in the wrong direction. I'm just going to leave it the way it is. And then there's an, I don't remember that letter, was that, the pulley was that F, right? Yeah, so there's FX and FY. And then the far right-hand side is some point D, and so that's dx and dy. Whoops, dy. All right, and so we'll do the same thing. Sum of the forces in the x. I have cx plus fx, but I know what fx is, plus dx. So I've added another unknown in here. That's going to equal 0. Sum of the forces in the y. I have cy plus fy plus dy equals 0. Added another unknown in there. And then I can do the sum of the moments, and I'll do the sum of the moments around C. Cx, fx, and dx all go away. They apply no moments because the line of action goes through C. Cy is at the point of interest here. So I have fy and dy. They're both positive, which means one of them's wrong, and that's fine. So fy, but I know what fy is, times this distance, plus dy times this distance equals 0. So we go to look for those distances here. And I know that this is 1 foot for f. It's a distance of 1 foot, and d is at a distance of 2.5 feet. So this is 1 foot. This is 2.5 feet. All right, and I know fy, so I can solve this for dy. So that's going to be a known value. So dy is a check mark, cx is a check mark. 1, 2, 3, 4 equations. 1, 2, 3, 4 unknowns. Looks like I might be able to get those solved. Pretty sure anyway, it doesn't matter. We still have one more member to do, and that's EDB. All right, so let's take a look at EDB. So that comes over here at this angle. So that's EDB. So B is down here, and I know what that is. And then I have EX, EY, and then I'm going to have over here, I'm going to have DX and DY. And so those become the equations then for this. I need those. So sum of the forces in the x, I'm going to have EX plus DX equals 0. Sum of the forces in the y, I have EY plus DY plus B equals 0. But remember, I know B from the very beginning of this problem. And then sum of the moments And I'm going to take the moments about, I'll take the moments about D. And I'm going to get B times this distance in here, which is, let's see, 1.5 feet. And that's counterclockwise. And then actually minus, because these are going to both be, if I'm rotating around D, E sub x wants to go clockwise, E sub y wants to go clockwise. So E sub x times this distance minus E sub y times this distance, and that's going to equal 0. E sub x should be 2 feet. E sub y should be 2.5 feet. Okay, let's take a look at that again. I'm going around D. E sub x is up here. It's in that direction, so the distance from here to the line of action, that's 2 feet. And the distance from here to the line of action of E sub y is 2.5 feet. Okay, and that will give me enough equations to solve for all of the unknowns, all of the points of interest. If I have too many equations, they should be consistent. If not, we have a real problem. And I haven't solved this out. I'm going to assume I did it all correctly and everything is good. But keep an eye on that. You could be over-determined. That's a bad thing. Unless everything works out nicely. All right, so there's a frame. You can see systems of equations, lots of equations to work with. But that's how we'll end up getting everything that's going on inside of this frame. All right? If you have any questions on that, please leave them in the comments below. Thank you.